Students, welcome back to part 2 of lecture number 13. So, part 1 we mostly discussed about decision tree or DT and their different formalisms. So, let me go into another classification problem, what is known as a support vector machine. In short, it is called SVM. SVM can be used with regression also, linear regression, nonlinear regression also. This is a classification aspects. So, let me start the problem, very simple. Let us say I have two types of data, okay. This is widely seen in medical diagnostic, like whether a tumor is benign or malignant. So, you can either have benign tumors or a malignant tumors. So, one can represent a +1, other can represent a -1, correct. So, you have this kind of, this is the way data available to you. Now, you have to divide a classification algorithm to separate this data. Let me explain what do I mean. So, what I mean is very simple thing, that suppose you have to use machine learning algorithm and to detect whether a new patient has a tumor and this tumor whether it belongs to benign or malignant. How do you do that? Okay, many times probably read newspaper that there is a machine learning algorithm has been developed by some kid, some school children or some boys in college, and they can detect a certain kind of cancer, okay. That you probably seen that, but how it is done. It is basically a classification problem. You classify these two set of tumors, one malignant, one benign, by using classification algorithm. So, how do you do that? This is what is the data, right. So, shall we draw a straight line like this and do that? What do you think? Let me try. So, this is a straight line, right. Can you see that? So, it is clearly separate two sets of data, the dots which are black field and the dots which are unfilled, they are separate out. So, my job is done, answer is no. I can draw a line like this, I can draw a line like that, I can draw a line many lines, correct. So, which is the best line? How do you know that which is the best line? So, let me go back again and explain too. So, this is the first line I drawn, which is going in this between these two plus and minus data points very nicely. I can draw a line like this, which is also good, right. I can draw a line like that, that is also doing my job. So, finally, you can draw many lines. So, now you understand the problem, right. So, what is the best decision line that can differentiate plus data and minus data nicely? That is what is the question here we are going to answer. So, what I will do in order to explain this problem, I will go back to the board and explain to you nicely, okay. So, then you can probably understand better. So, let me just draw 3 different plots first. And explain the problem nicely. Please concentrate so that you do not forget. So, you can see, for the sake of simplicity, I have taken 2 negative points, 2 positive points in each of these curves. Am I clear? I do not want to draw all the points, then it has become very clumsy. I have taken 2 negative points and 2 positive points in each of these plots. So, and I am asking a question, how do I draw a boundary between these two? Okay. Support vector machine is basically a decision boundary problem. Okay. So, this is nothing but a decision boundary problem. Remember this. Okay. This is a decision boundary problem. So, I have this kind of data. I can easily draw a boundary line like this. This is called nearest neighbor. This kind of model is called nearest neighbor based modeling to differentiate these two data points. You can also have one dimensional tree, right. I have done simply a line, that is why it is called a one dimensional tree, you can see that. I can also draw a neural net. Okay. Hope you follow me, right. So, all these are actually talking about a boundary. This is a curve boundary, this is a straight line boundary, this is also a curve boundary. So, these all are going to do my job, right. Question is, which is the best? Which one is going to provide me the best decision making capability? Answer is none of these can provide you best decision making probability. Okay. So, in this aspect I like to go back, I draw another plot and tell you how things are done. Okay. So, again negative points, sorry. So, let us draw these two negative points, these two positive points, right, little bit differently. You can clearly see that. So, what we can do is, since these are not going to provide the best solution, we can draw a road. So, first draw the center line of the road, right. This is my center line of the road. Any road, if you go on the walk on, there will be a center line, right. You can see that center line. Now, using a different color, I can draw the boundaries on the both sides. So, I shall draw the boundary in such way, let us say I am drawing the boundary such way like this, draw the line and then I can do that. So, I have drawn two lines, one on the one on this side which is just touching the positive point, one on this side which is just touching on the. So, one on the right side of yours or mine, if I stand like that, on your right side of yours, that is this red line which is just touching the positive point, one on the left side is just touching the negative points. Okay. So, now as you can clearly see here, very easily you can see this is just like a road with a center line and the two gutters on the both sides, right, that is what it is. So, now if you look at in India, so the vehicles will travel, so vehicles will also always travel from the left side like this, right side like that, right, correct, which is your left, no I am wrong. So, this is your left, so left vehicle will like go, right it will go like this, right, that is what it will go from left to right. So, now the question is, if I want to make my decision better, that means what? If I have a new data points, whether I can guarantee that data points will belong to plus or minus, I can tell you easily, then I have to maximize this width, right. The width of this boundary or road must be maximized, right. This must be maximized. Why? What I am doing by this way? By doing that, I am simply increasing my decision making capability, right, from this part to this part. So, any data point which is falling here, falling on this part of the road beyond this center line is going to be positive, right, any data points. Any data point falling on this side of the road is going to be negative. This is the center line, right. So, if I make this width as big as possible, I will not have any problem in putting these data points, never I will have any problems. This is exactly I am talking about it. So, let me explain you again the technique which is SVM stands for. So, what I am doing is simply first drawing a center line. Okay. First I draw a center line which is passing through this road, I can see that. Okay. Then I draw two lines, one on the left side, on the right side, one on the left side is this side, right side this side, you stand like that from your side. So, this line is simply touching the negative point, this line is simply touching the positive point, right, which is sitting at the boundary. So, that means these two are my gutters, this is my center line of the road and vehicles can move like that. So, anything which is falling on this side of the road is a positive, anything which is falling on this side is a negative, right. You may say anything falling on the center line, what will happen, we will talk about it later, that also can be handled actually. So, but as you clearly can see that compared to these lines or curves, this is a much better technique, much better technique compared to these lines or curve, because here you have only one boundary, here you have a width, definite width of the boundary, right. This technique was discovered by a Russian scientist, his name is Vladimir Vapnik. He discovered this technique sometime in 1970s when he was working in a hospital, and he has lot of data, but he discovered it, but nobody came to know about it. In only 1990s he was basically got an invitation from Bell Lab in US, and he visited that lab, and at the time, based on his mathematical and geometrical construction, he wrote 3 papers to different journals, but all these papers were not accepted. So, he was very unhappy, he thought he may be not 100% correct, but one evening dinner in a cafe, he met a scientist from Bell Lab who was working on similar kind of problems, but using neural net, this one. Then he said, Vladimir said, if you use my technique, I can guarantee you that you will get better result. So, then they started working with together, and then finally develop kernel, develop this programming for that. In 1990s there was Python was not available, so they used to write codes in C or C++, and that is what actually they developed this kernel, and this has become a household name. So, Vladimir Vapnik is a household name now after his classical work on support vector machine, because this is one of the widely used classification technique for machine learning or AI. So, now the coming back to the slides which I discussed, let me go back to the slides again, I discussed you on the board. So, you see I showed you I can draw many lines, right, but line is not a solution. So, then I told you it is better to define a margin, correct. So, better to define a road, you can see there is a road I drawn, and you can see there is a black line which is called the center line, like in the board I have shown you, this is a center line, and then is a definite width. So, define the margin of a linear classifier as the width that the boundary can be increased before hitting a data point, right. Please try to understand that. So, this is your linear classifier, you are feeding the data and finding out what is correct, right. So, that is what we did, we simply drawn a center line and then we drawn a road, and then we are saying the width of the road has to be as large as possible. You can see this is much better, right. So, maximum margin is what is required. This is the simplest possible SVM we can think about it. Sometimes it is called linear SVM or LSVM. So, maximum margin principle is what is to be used. So, maximum width or maximum margin is same. So, this is width, or you can write down margin also, right. This is also margin also you can write down. So, this is what needs to be maximized. Okay. So, now these data points here, you see there are few data points which are just touching this boundary. You can see here one, there is another, there is another one, right. Can you see it clearly? These data points. So, they are all touching, and in the board also I have drawn the similar thing. I have drawn the right side line which is touching the positive data points, and left side line which is touching the negative data points. They are all touching each other. These data points are called support vectors. Why they are called support vectors? Very simple. These data points here, you can have many actually, you can draw many such data points, right. These data points are holding the margin, that is why, or supporting the margin, that is why it is called a support. So, these data points are supporting the margin, that is how we can draw this line, this boundary line, okay. That is why it is called a support vector, and since the machine learning algorithm is called a support vector machine, right, that is how the name came. So, hence I need to have a larger width of this road, so that I can push the points to the extremes. Okay, that is the idea. This can push the points to the extreme point, the extreme sides. Okay, that is exactly the case. So you can, these are the data points that margin pushes up against. These data points, which is marked by this green color, these data points are basically pushing the margin up, pushing these data points nicely. Okay, that is what you can clearly see nicely here, that how this is done. So now if you increase the width, how you can increase, you can draw many kinds of these roads, many different constructions possible, many different angles. So one of the road which has the maximum width is what is used for support vector machine, right. So intuitively this is feels very safe to travel. You have width, cutters are far away, so car can easily move. And secondly, if we make a small error in location of the boundary, let us say, okay, it has been jolted in this perpendicular direction little bit, this is gives us a least chance of causing a misclassification. So what I mean, so if I make a small mistake in drawing the line, okay, a little bit, let us say I push the line little farther on the right side, still because I have drawn the center line nicely, still I will not make much mistake in this classification of the data points. This is the advantage of using this kind of techniques. So therefore small errors will not make much difference, and this kind of techniques, linear techniques, is very easy, since the model is immune to any kinds of removal of non-support vector data points. That means very simple one, very easy one. And there are some theory like which is related to the proposition of this kind of things good actually, but that does not matter. Try to understand that empirically it works very nicely. This is probably one of the best classification techniques we can think about it. Okay, this I believe one of the best classification techniques we can think about it. Now let me go back to the board and tell me how we can mathematically handle this problem. Maybe we may not be able to solve the problems properly. So let me erase this out and draw this diagram again and tell you how we can do that. So I will take the liberty of drawing this diagram in a much bigger way, so that it is very clear to you. So I said there are negative points here, there are positive points there, right. And then I said let me first draw the center line, correct, you understand that, and then I will draw what, I will draw these lines. Okay. And I said that I need to maximize the width of this road. So how do I do that? That is the question, right. So maximize the width of the road is what is the requirement. Let us say you want to do that, I will explain the theory behind it. I may not derive any mathematical relationship today, the next class I will draw that derivation. Okay. Let us say I have a data point here, and that obviously belongs to positive, right. So what I do, very simple, I simply draw this line like this, correct. So now this is simply connection of these points with the origin. So now if you draw a vertical line from this, correct, this is the distance of this line to these data points, correct. Is it clear? This is what is your line which is connecting the origin of this curve and the data point, correct. Data point can be here also. So then you connect this, and then you can draw a perpendicular line like that, right. So let us focus on this one. I just give you example, otherwise picture will be cluttered you may not understand properly. So, I have a data point, first I connect this and draw a vertical line. So, now if I project this line onto this, correct? Am I clear? Or rather I should tell in a much better way. So, if I project this line onto parallel to this width, okay, project this line parallel to width, and if this distance is going to be larger than this distance from these two center line, then I can say this data point must belong to positive. But if this projection onto this width falls short of the center line, then this data point must be negative. This is the idea. So, therefore, I can draw this line which is connecting the data point with this origin, and I can always project this line onto this width perpendicular line connecting between these two ends of the road, and if that actually once is done do that also falls beyond this center line, then it is a positive point, but if doesn't it falls short of the center line, fall this side of center line, that is a negative point. Okay, that is the idea. So, basically I need to calculate, if this is my vector, I need to calculate what will be the width, what will be length of this vector once I project on this. That is what I need to calculate. So, once I calculate this vector length upon projecting onto this, and that length is larger than or as it falls above this dotted line or center line, then it is a positive point. If it falls below this center line, it is a negative point. This is the fundamental idea by which this whole thing works, the SBM works. Okay, SBM works on this fundamental idea. That is what we do. Okay, we always try to figure out that, and then next class when I come back, I will talk to you about the decision rules and how this small mathematical formulae can be used for as a decision rules. Then in the next class we will discuss in details about that. So, let me stop here, we will come back to it. In the next class we will discuss about lecture number 14, more about SPM, and try to wind up the next lecture. Thank you.